In this video, we are going to go through the example of independence test. A study was conducted to see whether the injuries sustained by motorists were dependent on the type of vehicles they use, and the following data were collected. So here we have, this is the category for vehicles, where we have two types of vehicles, motorcycles and car. And for injuries, there are two categories for injuries, which is minor and serious. Test the hypothesis at 0.05 level of significance. So for this question, we want to see whether the injuries are dependent or on the type of vehicles or not. Okay, so first of all, we will define the hypothesis. Okay, so the hypothesis will be, the null hypothesis is the injuries and types of vehicles are independent, and the alternative hypothesis will be injuries and types of vehicles are dependent. Okay, that is our hypothesis. Okay, next is we want to find the critical value. So number of rows is given as 1 and 2, and also number of column we have here is 2. So degree of freedom would be the number of rows minus 1 multiple with number of columns 2 minus 1. So 1 times with 1 is equals to 1. So using the significance of level 0.05 and degree of freedom, which is 1, so it is equals to 3.8415. The next step is to find the expected value. So here we know that the formula for expected value is finding the row sum multiply with the column sum divide by the total sum. So let's find out the value for each row. So here to find the first row sum, it will be 50 plus 200, which is equals to 250. So this is the row 1 sum. Okay, next is the second row sum, which is 150 plus 30, which is equals to 180. And then for the column 1 sum, will be 50 plus 150, which is equals to 200. And for the column 1, okay, this is the column 1 sum. And for the second column sum, it will be 200 plus 30. So it will be 230. So the total sum would be 430, which means that the value for this one, the row, should be equals to 430, and also same goes for the column. Alright, so now we have found all the values for each sum for the column and also for the row. Next is to find the expected value for each cell. So here for E11, it will be the row 1 sum multiply with the column 1 sum divide by the total sum, which is 430, and we will get 116.28. Okay, next, so I'll just write the expected value here is 116.28. Okay, so this is the value of the expected value, and this is the value of the observation value. Okay, and then for the second cell, which is E12, which is this one. Okay, so it will be the summation, the row sum the first row sum, which is 250 times with the column sum, which is 230 over 430 equals to 133.72. Okay, next is for the 2-1 column, 2-1 cell. Okay, so the expected value for this would be the second row sum multiply with the first column sum divide by 430 and we get 83.72. And the last one will be the second row sum multiply with the second column sum divide by 430, which is equals to 96.28. So the observation value would be 96.28. Okay, now we have found all the expected value. Next is to find the chi-square, where this is obtained by taking the summation of OI minus EI square divided by EI. Okay, given that O is the observation value and E is the expected value. So this is, okay, so for the first cell, it will be 50 minus with the expected value and square this, divide by the expected value plus with the the first row second column would be 200 minus square over 133.72, and then for this column it will be 150 minus with the expected value and plus with the final cell, which is 30 minus 96.28 square over 116 over 96.28. So you will get the summation of 168.73. So this is the value of our chi-square. So now we can make decision given that the critical value we have is 3.8415 and our chi-square test is equals to 168.73. So given our chi-square is greater than the critical value, which is equals to 3.8415, then we can say that we have to reject H note. Okay, which means that there is sufficient evidence that the type of vehicles and the injuries are dependent.